Patience is a virtue, and you've all been incredibly virtuous. We are finally back to upgrading our Sovol SV08 MAX, and this time we are adding all the missing pieces we've been teasing. We'll show you our completed, custom-designed, dual material top riser brought to life with the help from our friends at PCBWay. How we permanently silenced the jet engine idle noise with a simple and cheap fan upgrade from AliExpress. The easy way to insulate the entire enclosure for better heat retention and sound dampening. And finally, the perfect lighting solution to illuminate the massive build chamber along with an elegant fix for its unexpected problem. How did it all turn out? And what are these pieces in front of me? Let's get into it. Yes, this is gerGO. And a warm welcome back to gerGO Print 3D, the YouTube channel where my little nephew Levi and I do our best to bring out the most from our tech, the coolest 3D printers, the hottest laser devices, and other awesome DIY tools. If you're new here, check out our back catalog. Just like our previous videos, this one has curated, translation-ready subtitles, detailed chapter markers, and now even audio tracks in a dozen languages. Let's kick things off with our dual material top riser, because this is probably the most exciting of all. Just look how perfectly this thing matches the stock enclosure. It adds a comfortable 150 millimeters of extra Z height, giving plenty of clearance for the filament tube and cables, even at the very top of the build volume. What makes our design unique is the way it incorporates these transparent acrylic panels, which keeps the riser incredibly lightweight and dramatically improves visibility inside. Now, unless you have a CO2 laser the size of a small car, cutting 600 millimeter wide acrylic panels is probably not on your weekend to-do list. And this is where our sponsor, PCBWay, comes into the picture. They can turn your designs into reality. And they shipped our panels to us in this practically bomb-proof mini crate. Every panel arrived in pristine condition, cut to a phenomenal accuracy, with every single screw hole exactly where it needed to be. I've published the CAD files on CALS 3D, but if you want to use PCBWay, the process is even easier. Just follow the link to my shared project, set the material to 3mm PMMA acrylic, and you'll get an instant quote. I declared it as a plastic enclosure for customs, and while the panels arrived in my city just 5 days after ordering, my panels decided to take an extended 10-day vacation in local customs. Nothing is as bad as EU bureaucracy. I'm sure your delivery will be much more direct. Of course, PCBWay could also produce the 3D printed components, but so can your Macs. I printed the prototypes out of PLA and the final pieces out of ASA and PETG. And you don't want to skimp on the settings here. We are talking Voron standards, 0.2 millimeter layer height, at least 4 walls, 5 top and bottom layers, and 40% 3D honeycomb infill. Most components are easy prints with minimal supports needed only at their very bottom. I did fight with ASA bed adhesion though. A heated chamber and using a glue stick on the bed was the solution. But I had to give up on using ASA for the 625 millimeter long top bridges. And that wasn't even the biggest problem with those, as we'll get into in a minute. By the time the panels arrived, we had all the 3D printed pieces assembled using temporary corner placeholders we cut out of plywood. We used the screw holes on the original top frame to secure the corner and center pieces with 15 M3x10 screws, and you'll be able to use the original screws to attach the metallic half of the top lid and the filament arm. We added heat set inserts for these and also for holding the acrylic panels. Altogether, that's 42 heat set inserts, so a stealth press like this will come in handy. Check out my earlier video if you haven't built one yet. And then came the rude awakening. As we popped in the beautiful clear acrylic panels, the screw holes on the long top bridge pieces did not line up. Of course they didn't. PCBWay cut them exactly as designed, but my 3D printed pieces, even these PLA prototypes, actually shrunk. 3D print shrinkage is real. While a fraction of a millimeter of clearance can make up for it in normal everyday prints, even PLA's 0.3% shrinkage will cause several millimeters of difference in a 625 millimeter long top piece. We make mistakes so you don't have to. My designs as published on the Cult 3D project are correct, but you'll need to scale them up by the shrinkage of the material you choose to print them out of. 100.6% for PETG, 100.8% for ABS, and a whopping 101% for nylon. But make sure to calibrate your specific material. And be sure to let all prints cool slowly, giving them an hour or two to reach room temperature to eliminate any internal tensions. With the properly scaled parts, everything fits together like a dream. It's strong, effective, and looks like it came straight from the factory, or even better. A massive thank you to PCBWay for sponsoring this video and making this ambitious upgrade possible. A Monport Reno 65 Pro CO2 laser is on its way to our workshop. We'll be using it to etch the name of the printer and the big PCBWay logo in the clear acrylic when it comes. Stay tuned for that. Speaking of what's coming, don't just rely on the YouTube algorithm to show you that video. Stay in control by hitting the subscribe and notify buttons to make sure you don't miss our next Sovol adventure. Thank you if you already did. All right, the upgrade you've been messaging me about, silencing the idle mode. Let's be honest, it's a bit of a brute force solution. Our beta unit came with two noisy 4010 fans making this high-pitched whining sound, running at 100% speed independent of the actual temperature of the controller board. My friend 3D Print Damon replaced them with expensive Noctio fans on his. Others have adjusted the printer configuration to control their speed based on the host temperature. I simply got on AliExpress and picked up one of the cheapest 80mm fans I could find, specifically a thin 10mm 24-volt variant with a 2-pin XH 2.54 connector. Then I grabbed my Dremel, the real deal, not a knockoff, but also from AliExpress, and cut a large hole in the bottom panel. And a little pro tip, use a sticker as a template to get your cutout location perfect. 2 M3x16 screws and nuts secure the new fan, and since it's a thin 8010 model, it fits inside with plenty of clearance. Make sure its sticker faces inward to blow air onto the controller board. I plugged it into the fan 1 connector, and that was it. This single, larger and quieter fan breathing through an unobstructed opening is more than enough to replace the two noisy ones we removed. It's so quiet now that I haven't even bothered with thermal speed control in Clipper, though I might add that later. These cheap fans might only last a year or two, but at this price, I already bought a spare. I've put links to the exact fan and the Dremel I used in the description, along with some coupons to save you even more. That was a cool and cheap fix, right? If you agree, how about letting us know with a like below? It's a huge help for the channel and we really appreciate it. And while you're shopping on AliExpress, you might as well grab 10 meters of 10x2mm foam tape and 5 meters of a cob LED strip because you're going to need them for these next two upgrades. First, the foam tape. I already told you, but would you have guessed we would need this much insulation tape? 10 meters. This printer is huge and we want to add it to every side of every panel. It will help with both sound and heat insulation. It has an adhesive back, so installation is extremely easy. Just make sure to get the 2 mm thick and 10 mm wide variant. Apply it to the very edges, make cutouts for the screw holes, and cut the ends at a 45-degree angle for clean corners. Our top glass panel already had foam, but we added it to the metallic half as well, and most importantly, to the edges where the two front doors meet. As Levi noticed,
there is a really big gap, so
sticking the tape on the inside of the door with a slight overhang so it can be bent over the very edge will fill up that gap between the doors perfectly. They now press together snugly, which is incredibly satisfying. There are hairline gaps where the doors meet the frame as well, but there is not enough space there to add insulation without exerting unwanted force on the hinges or making the doors impossible to close. Now all this screwing and unscrewing of panels brings me to a tool we've been using constantly for these kinds of projects, our Hotto Snap Block Precision Screwdriver set. You probably saw Levi using it to secure the riser panels, and it was perfect for me when I reattached the bottom cover after installing the new fan and getting all these enclosure panels back on. The magnetic bits and comfortable grip make these repetitive tasks so much faster and easier. We are big fans of our Hotto tools. You can find links to them in the description below, and don't forget to use our code gerGO15 for a nice 15% discount. I chose this type of cob LED strip because the adhesive back makes it very easy to install. We went with a 4000 Kelvin natural white, but make sure you get the 24 volt variant. 5 meters sounds long, but it's the perfect length to go around the top frame and down the front right corner right behind the chamber camera. For wiring, we are replacing the secondary LED panels. You'll need to remove those and solder an SH 1mm plug matching red to the positive wire. You can find links to these plugs in the description, or just snip one off from the old LED 3 extension cable we removed. And wow, are they bright! They completely overcome the dark tinted glass, which gives the printer a premium look when off, but can make it hard to see inside during a print. Not anymore. Now, I did run into some flickering. I noticed it started the exact moment the nozzle reached its target temperature. It turns out the PID controller rapidly pulses the heater to maintain a stable temperature, and these power fluctuations were causing the LEDs to flicker. Luckily, the fix is just one line in your printer CFG. Under the extruder section, add PWM cycle time 0.02. This boosts the heater switching frequency from 10 Hz to 50 Hz, which is too fast for our eyes to notice, and your video camera will thank you for it also. An important note here, after adding that line, you must run a new PID calibration for your extruder and save the config. This ensures your nozzle temperature stays rock solid, and with that quick change, the flicker is gone, leaving just perfect, stable illumination. By the way, this flicker prevention trick is just one of the many improvements in Demon Clipper Essentials, an amazing software overhaul by 3D Print Demon. Just look what happens when Levi pushes the filament into the auxiliary feeder now. No need to press any buttons, and it can also feed out all the way. And look at the screen. It now asks you whether you want to load or clean load. Choose clean load. So after all these hardware mods, the next video in our series will be a deep dive into upgrading the software experience. You won't want to miss it. Oh, and before we sign off, I bet you're still wondering about all these parts in front of me. Fans, heating elements, PCBs. thermistors, and 3D printed cases. Well, you're looking at our next big project for the Max, a full chamber heating solution, the iHeater. It's going to get its own dedicated episode very soon. If you missed the first part of our Max upgrade series, where we took a close look at our auxiliary feeder, you can watch it right here. And if you're planning to print high temperature filaments, the 100C iDryer is your best option. We explore it with Igor from MyTechFun in this video. Now with your fully upgraded SV08 MAX, it's time to go print 3D. Thank you for watching another gerGO Print 3D video all the way to its end. Now go make it better.